We spoke previously about Newton's first law, that objects move at a constant velocity with zero acceleration unless acted upon by a force. But what is a force? A force is a push or a pull. It has a strength and a direction. A quantity with a magnitude and direction is called a vector. We'll talk more about vectors in a few videos. We are already familiar with many kinds of forces. We now know that they are all manifestations of a few fundamental forces. All forces come from the interaction of two objects. We'll now go through a list of some common everyday forces. Weight is a force downwards due to gravity. This is from the interaction of an object with the Earth. When we're working with forces, it's extremely useful to draw a diagram of all of the forces acting on an object. This ensures that we don't forget any forces and that we know which direction the forces are in. We call this a free body diagram. Note that weight is not the same as mass. If you went to the moon, your weight would be less than it is on Earth due to the smaller gravity on the moon. Your weight actually also changes as you move around different locations on the Earth. However, these changes are quite small, so we usually don't notice them. Another useful force is the spring force. This is how we make the most of forces in machines or in biology. When we extend or compress a spring, there is a force back towards the original position of the spring. It's clear in this case that the force is a vector, because the direction of the spring force depends on whether we extend or compress the spring. When we pull on a rope, this produces a force in the same direction as the rope. This is known as the tension force. The normal force is an incredibly common force, which is all around us. It's why we think of objects as solid, and the reason why you don't fall through the floor. It might seem like a strange name, but the word normal comes from maths, meaning perpendicular to a surface. The force of friction opposes the motion or the attempted motion of an object and is parallel to the contact surface between two objects. If an object is moving, then the force on it is called kinetic friction. For example, a puck on ice slows down to a stop due to kinetic friction. Friction can also act on stationary objects. For example, if you try to push a parked car, it won't move, even though you're applying a large force. The friction here is called static friction. Usually static friction is larger than kinetic friction. So this means if you push on an object and get it to move, the force you need to keep it moving is smaller than the force you needed to get it moving in the first place. In these free body diagrams, we've just drawn one type of force on each diagram. However, in many cases, there will be more than one type of force acting on an object. Let's consider an example where we have a stationary book sitting on an angled desk, and we'll draw a free body diagram showing all of the forces. There's weight, which always acts downwards. There's the normal force, which is always perpendicular to the surface. And then there's friction, which opposes the attempted motion. It might be useful to think about what would happen if there was no friction. For example, an icy desk. Then the book would slide down the desk. So in this case, friction is upwards and parallel to the desk. If the book is not moving, we know from Newton's first law that there must be zero net force, and so these three forces must all balance. It's complicated to see exactly how these three forces could cancel each other, because they're not all in a straight line. So we'll leave this problem here and come back and solve this quantitatively in a few videos' time after we've learnt about vectors.